right. Well, thank you everybody for joining me today. Last session of the conference. Hope everybody's had a really good time. I know I've had a lot of great conversations. To introduce myself, my name is Michael Krueger. I am the Senior Director of Application Security at NowSecure. I run NowSecure's penetration testing team, 18 mobile reverse engineers, network analysts, subject matter experts, all in mobile security. So NowSecure is a mobile-first, mobile-only company. We are one of 6 App Defense Alliance authorized labs and the only global OWASP mobile application security advocate. We are also project sponsors of FRIDA. I think met a couple of you talking about FRIDA this conference, as well as Radare, or R2, which is a reverse engineering framework. But today, let's talk a little bit, start with some statistics. I'll get the boring stuff out of the way first. So 80% of apps that we have tested, we test lots of mobile applications. My team alone tests hundreds and hundreds of mobile applications for healthcare, financial, US government, state, local, federal. We test a lot of apps. 80% of those failed their first assessment because they did not prepare their code properly for release. So there were debugging issues, there was debug code, debug symbols left in the application. 75% of the apps that we've tested actually failed due to a misconfiguration of a cryptographic library. So you're relying on those crypto libraries to protect your sensitive data. 75% of the apps that we test actually don't protect sufficiently. 85% of the apps that we've tested failed their first validation assessment due to vulnerabilities introduced by third-party dependencies. So now you're using code, open source code, code from commercial entities, and they are introducing vulnerabilities into your code base. And 4 out of the 5 SDKs that introduced vulnerabilities into the app were already aware that an issue existed, and they weren't doing anything about it. So, the challenge here, saying developers, I'm a security guy. I could stand up here and say, you know, developers, we need to develop secure, trustworthy mobile apps. That's easy, but providing consistent, actionable, accurate guidance to development teams in order to actually design secure mobile apps, that's the hard part. The resources aren't out there. They're incomplete. They're inaccurate. They're out of date. You know, 3.4 million cybersecurity jobs in various disciplines are unfilled currently. Why does that matter? Well, when there's a cybersecurity shortage, often that expectation, that job requirement, falls down on developers. So now you already have tight release schedules. You already have complex regulatory and compliance requirements that you have to navigate. You weren't educated for security. You weren't trained as a security professional, unless you're a security engineer, but you're now being expected to take on multiple jobs. Now you've got your development job, now you've also got a security job. Historically, most application security tools are slow and bury developers in alerts that make their jobs feel impossible. Rather than helping them, developers are often forced to choose between speed and security. Guess which one wins? That was a quote from Forbes this year, and their application security is not a developer-first problem. But there is a light at the end of the tunnel. Let's talk about OWASP. The Open Web Application Security Project has a mobile-specific mobile application security project. This flagship project is 100% geared towards an industry collaboration of securing mobile applications. Now, you see security a lot throughout this. Security, security, security. But guess what? It's not just for security practitioners. So a little bit about OWASP and what they've developed. They've developed the Mobile Application Security Verification Standard, or MAS-VS. They've divided this standard into multiple different controls and different categories. So first category, storage. Well, We all know we need to protect your secrets and your users' secrets from lost, stolen devices, malware compromise. We know we need to do the right thing with cryptography. We need to prevent those common misconfigurations. And we all know auth is important. Trust in the client is risky. We've heard other talks today, yesterday, about how important authentication is. I also care about our network communication. Who are you really talking to? Make sure your users are communicating with your endpoints and not an attacker's. We know that the platform is important. Who you're operating on. Well, we need to make sure that the apps are properly social distancing, right? You don't want your app talking to another app unless you intended that app to talk to another. We know that we need to care about the code quality, security best practices for data processing. We need to keep the app updated. And finally, we care about the resilience of the app. So make my team's job harder. Make it hard for us to do what we're trying to do, which is compromise the app and ultimately uncover security vulnerabilities. The goal of MASVS is to make all of this harder for an attacker to glean important information, to gain a foothold, to gain a compromise. This guide, this standard is all geared around mobile application security, and it's kept up to date. Unlike a lot of the other standards out there that are heralding back to 2015, 2016, MASVS or MASVS keeps up with the times. They're always working with industry partners. They're working with Google. They're working with mobile application security experts. They're updating everything to make sure that security practitioners, but also developers, are getting the most important information. So how does one use MASVS? Well, you can use it as a metric, sure. You can use it during procurement to provide a baseline for, your mobile apps that you're looking to procure. But what we're here to talk about today is as guidance during all phases of the mobile app development and design. So that's the important part. It can not only be used as a security and compliance specification, but it can also be used, and this is the important part for developers, can be used as your guide for what to pay attention to as you're designing, as you're developing your applications, because this is the standard that brings all other standards together. This is the expectation that you can expect that you would be held to. So what else do they have? Well, they also have another program called the MAS-TG, or the Security Testing Guide. Now, classically, yes, this has been geared towards security practitioners, but here's the interesting thing. Let's take the network category, for example. So in the MAS-VS, the network category has multiple different controls within it. One may describe, your app needs to operate on a secure network, or it needs to operate securely. However, the MAS-TG breaks that general requirement that the app secures all network traffic according to current best practices, and it separates it out into individual testing criteria. So now not only do you know that yes, and this should be a general assumption that yes, my app should secure all network traffic, but now you know exactly how you would be tested against that. So each one of these, the MAS-TG, goes into great detail. How might a security practitioner do this statically? How might they do it dynamically? What sort of tools might they use to look for a compromise or exploit a compromise? But they also provide guidance, recommendations, and remediations for developers on how do I avoid this? How do I avoid getting compromised? How do I avoid a security finding or a bug report or any sort of informational or risk-related finding coming back on my network communications or any other category for that matter? So now we have our standard, the MAS-VS, and we have practical guidance with the MAS-TG. So now, with these two combined, you can ensure you've got quality code. You can focus on preventing release blockers. And everything that we talk about today, and this is really what I want to hone in on, everything that we talk about today is real life issues that we see in applications that we're testing. And every single one of these Google also collaborates with industry partners on, and they prevent apps from entering the Google Play ecosystem because of these issues. So they will send notifications back out and say, you are not approved to release this version of your app because of these following reasons. Everything that we talk about today is in that list of reasons. All right, so I'm not just going to do the talking. I want every one of you to actually pay attention. Let's see how your trust and security mindset is. We're going to go through some examples, see if you can spot the issues. I've got some fun little things up here to give away, so shout it out as you know. Here's the first one. It's maybe a little tiny, so if you need to open up your phone and zoom in on that, I'll give just a minute or two here. Anything wrong with this code example? Raise your hand if you know it. It's a longer one, so I'll give you a few minutes. All right, I'm going to jump forward. So this actually applies to our Network 1 criteria. The app secures all network traffic according to current best practices. Well, two things it did not do. Number one, this is implementing a certificate validation scheme. So this is a custom trust provider that this user was implementing. However, they did two things wrong. Number one, the hostname verifier. Let's go back here. This part right here, this is supposed to validate that, let's say my client is expecting to be communicating with nowsecure.com and an attacker gets in the middle of it and they implement attacker.com instead, and they try to present that certificate as the valid Now Secure certificate. This hostname verifier, that's supposed to compare those two common names and say, no, those don't match. This isn't the valid certificate. However, this part of the method right here always returns true. So no matter what, I will always say that this is a valid certificate or a valid host name. So an attacker now can present any malicious certificate on behalf of the valid nowsecure.com certificate. But there's more. Check server trusted, check client trusted. Those are actually checking the client validity. If there is an error with that certificate, say again that I produced a self-signed certificate or other invalid certificate, that my device is not configured to trust, I should throw an exception, right? Unfortunately, the certificate exception handling is empty. So in this case, no error actually is handled and nothing is done. And in the absence of any error handling, in this particular case, the certificate is considered valid. So these two errors combined will actually trust all certificates, or essentially eliminates all protection that you would have in SSL or TLS. So you essentially now, with this implementation, you would essentially have the same security as plain HTTP, even if you're exchanging sensitive data. Network 1 in MASVS describes in painful detail about all of the individual cases that you should consider, both as a security practitioner and as a developer, to avoid these particular cases. Now Secure also has a blog that talks about the network security configuration and how you can use that to also avoid some of the issues that I'm talking about today. All right, let's look at a different one. So, okay, my user went and they said, I understand, I fixed it. I've fixed my check server trusted. I'm now checking the certificate. Is this good?
Do they need to check all the certificates in the chain?
I'm sorry, say that again?
Do they need to check all of the certificates?
Do you need to check all of the certificates? Potentially, but not always. So this is misleading. Anybody know it? All right, I see a hand.
The
Correct? One other problem, check validity. So check validity, that function, it certainly checks if the certificate is valid. It checks if the current date and time of the certificate are within the validity period. It does not actually check if the certificate is valid for a trusted certificate authority. So I could still present a self-signed certificate as long as it is the date and time are within the valid issued time, it's still considered valid. So yet again, I trust all certificates. As long as they've been generated recently, as long as they haven't expired, they're still valid. All right, let's switch gears a little bit and look at a web view instantiation. What might be wrong with this one? Similar with the errors, okay? I see hand in the back and then you. Okay, you're on the right track.
Yeah, I was going to go with you're not throwing in an exception.
Close. In this case, this right here, handler.proceed, that ignores any error. So this on received SSL error is called by default whenever there is an error. So yes, correct, there should be. I'm going to give you both one. There should be an error. There should be exception handling, but what there should not be is a proceed routine. So this indicates, there's an error, that's fine. Okay, let's move on, ignore it. So this ignores all SSL errors. Now by default, a web view is an extension of the browser, right? The device's browser. So the browser actually handles the SSL, the certificate validation, right? By default, the browser does that for you. But in this case, this was overridden to handle, this particular app wanted to handle those errors themselves. Well, what they did, they handled it by ignoring all errors. So rather than handling the errors in a graceful way, they ignored them and proceeded on. Yet again, this is a third example of ignoring all certificate errors. What this does is all three of these applications were set up for a what's called a man-in-the-middle attack or a network interception attack. So by this, what was normally HTTPS traffic, what was normally encrypted traffic, was now able to be intercepted at any point during the communication. So when a web view is used, as I said, the mobile browser performs the validation, but ignoring those errors, bad practice. We commonly see these three issues. We commonly see it in QA or dev builds, but the problem is they don't always get changed over. They don't get commented out. They don't get debug-only routines. These are overlooked prior to release. The last one that I showed you is probably one of the most common blockers that will prevent you from getting on or updating your app or releasing a new app on Google Play. This is a common one that they call out. I'd also like to mention for each one of these, there is an MASTG reference, so a MASTG reference that goes into even greater detail on what you should look for, what you should avoid. All right, how am I doing on time? I'm doing well. All right, so let's jump into some cryptography now. This is a fun one. There is a problem. So this is instantiating a new cipher. It's an AES GCM. This is a little trickier because everything at first glance looks fine. Again, it's just a couple lines. But there is a problem. That first line is setting up an initialization vector. That's part of the cryptographic routine. However, if you're not using the platform-provided cryptography instantiations and you have the option to override them. You have the option to provide your own key, to provide your own initialization vector. They give you that freedom. However, in this case, the user chose, I'll generate my own key, but I want to create my own initialization vector. There are reasons why you might do that, but in this case, the initialization vector that you see here is 0 or null. Well, a null initialization vector is effectively worth nothing. And in cryptographic modes such as CBC, GCM, those are common ones. If you don't have an initialization vector, or if it's even predictable, then it essentially reduces the overall security of the cryptographic routine to one that's considered weak or broken right now. I think it goes a little bit more detail here in the MAS-TG, but they also say that ECB, or the electronic codebook mode, is one you should never use. So you're still given that option. Modern linters should throw an error and say, please don't use that. But if you do, you will see an error in modern, and definitely Android Studio. I'm not sure about a couple of the other IDEs. However, if you're using CBC or GCM, which are considered secure modes of cryptographic operation, and you do not use a properly random initialization vector, you know what that does? That reduces your security to the equivalent of ECB. So now what was looking like a secure cryptographic operation is now not. This is one of the most common issues we find. One of the most common. Now, while we're talking about crypto, who here knows about PQC? Post-quantum cryptography. I promise I will not get into the mathematics of this. They told me about lattice-based matrix math, and that was all I needed to know, that I was not smart enough for that. But within 3 years, we expect, and other experts, especially within the mathematics and computational fields, say within 3 years, the computing power will be sufficient enough to break all current cryptographic operations. So AES, RSA, all broken by the advances in quantum computing. So what was safe, the data that may have already been gleaned by attackers in the past that was still protected because it was encrypted, may no longer be safe. So are you ready for it? There's an excellent article from Now Secure's CTO right here that goes into more depth on post-quantum crypto. Definitely a really good read. He makes it approachable to everyone, including myself. So definitely recommend looking into some resources there. Now, NIST, National Institute of Standards. They have actually been working on the post-quantum crypto problem for, 7 years now? Yeah, 7 years they've been working on it so far, preparing for this point in the technology. They're in the final stages of approving different algorithms for use. The leading contenders right now are in the crystals collection. Kyber for public key encryption, dilithium for digital signature. These are the two current algorithms that we're expecting to be the final approved set for this new quantum age of cryptography. So from a readiness standpoint, can you easily swap out your current cryptographic operations? I think this is probably the most important thing to consider, is how long will it take you to swap out all of your crypto? How long, and what is the cost of that? We're not saying that everything needs to be switched over, because computationally that may not be feasible, right? Crypto, it's expensive. Resource-wise, it is expensive. Now, NIST takes that into consideration with the algorithms that they're recommending, but it's expensive. So have you inventoried that crypto? Do you know what you have in your app? and have you evaluated the use of these algorithms? So there are libraries that are already released. There is actually a sample library already out there specifically for Android. So if you search for PQC crystals, they actually do link out to several open libraries that you can start to evaluate for your particular use case. All right, now let's get back to the fun stuff. Here's another one. This one might be a little easier. This is something security always complains about. Again, a little bit in the encryption side. This is under another requirement, Crypto 2. The app performs key management. Well, this is a hard-coded key. That could be a way of key management, but wouldn't recommend it. Why wouldn't I recommend it? Well, reverse engineering tools can easily retrieve those hard-coded secrets. And this is where I think we're getting a little bit more fun, because I'm going to show you that. Frida. How many have heard of Frida while you've been here? All right, excellent. Dynamic hooking. That means that with Frida, we can actually tap in at runtime and dynamically observe every operation of the application, and we can even change it if we want. Now, let's see if the network, oh, good, it's going to support me. All right, so along the right-hand side here, this is an uncrackable app. I'm trying to get the hard-coded string that you just saw, and I'm trying to get the unencrypted version of it. With Frida, all I needed to do was enter in any string in that text box, and along here, along the left, I'm going to pause it for a second, if I can. Along the left-hand side, I know it's a little small, a little hard to see. Frida was watching that algorithm run. So Frida actually hooked that cryptographic routine, and if you look in the lower left, see where it says decrypted right here? That encrypted hard-coded key also was protecting a hard-coded string that was encrypted and decrypted it all on the fly in a matter of seconds. And that's that. That is right here. So this is that encrypted string. There's the key. Those two together, Frida was able to dynamically insert itself into this routine before it returned its value. And I was able to spit that out to the screen in a matter of seconds. All right, let me move ahead here. All right, let's look at this one. We're back to web views. If you attended the Google Android Vulnerability Research Team's talk yesterday, they might have given a hint about this one. Oh, let's go back here. It is. You see this right here, they're adding a JavaScript interface, and they're exposing this routine right here. Now this is a simple one. This is a capture the flag type app, and they're exposing the actual flag, the secret value that you're trying to get. So with this small little bit of code, if I could get your app to navigate to my malicious website, I could capture whatever token or flag that you have stored in your application. This is exactly how attackers get session tokens. Cookies off of your device. I've had arguments in the past with those that say, well, my device, you're not on it. How are you going to get information off of it? Well, it depends on the web view of the apps that you're using, but it doesn't matter what app you're using. Maybe I want information from that app. Maybe I want information from your device. This ingress point, this is a common way for attackers to get more information from your application or from the device itself. So, using the Add JavaScript interface, it may surface sensitive data or functions. You should definitely use that cautiously. If you want to see why we recommend that in detail, this blog post right here from one of my security team will show you how they use Frida, yet again, to exploit that exact feature. All right, before I start this, I had a conversation yesterday, actually with a handful of people, talking about secure storage and the fact that they could use, as long as the device wasn't rooted, probably okay. And they said, well, I'm going to implement root detection in my app. So as long as my app's not running on a rooted device, I don't need to worry as much about the storage, right? I don't need to worry if I'm storing a key or other sensitive data. Maybe I'm not encrypting it. Maybe I'm storing it in plain text. I don't need to worry because as long as my app won't run on a rooted device, I'm okay. So here's an example of an app running on a rooted device. They have root detection. Uh-oh. Well, the app's going to exit. Okay, I'm defeated, right? Wrong. With Frida, yet again, all we need to do is observe those routines. Okay, so there it is again. Roots detected. Okay. So I just need a small little script, which is pretty simple. But first, what would an attacker do? Well, they would open your app up in a reverse engineering tool, something like JADX, which basically quickly decompiles your code into very human-readable code. Not an exact replica, but enough to actually evaluate it. Okay, you can see I'm actually able to get pretty legible information back on the app. I can learn, oh, look, there's root detected. So I know, I can probably guess at exactly how the app is starting to do its root detection. JADX actually has a really handy feature where I can right-click on a method that I'm interested in, that I want to watch, or maybe override, or completely eliminate. I can just right-click on it and say, send to Frida. I don't even need to write code anymore. It will write it for me. So in terms of the attack surface, the ease at which these attacks can now be crafted, it's pretty staggering how quickly you can do that. Let me move ahead a little bit here. Here's the result. So I run my script. No more root detection. You can see right here along the left-hand side, I hid myself from all of the root detection methodologies. It had 3 different ones it was looking for. It was looking for the presence of the super user daemon on the device itself. Well, I hid myself from that. That was easy. Instead of saying, I just overrode the routine that the app called, and I said, no, no SU here. I convinced it that it was operating on a production build of Android, and I hid any root-specific files from the application again. And that took, I think, 15 lines of code to do. Yeah, and there it is. That's all it took. That little bit of code allowed me to defeat root detection. A lot of developers use root beer. That's a common root detection platform. It's about as easy as that to overcome root beer. So why are we talking about this? Well, resilience. Resilience 1, resilience 2, they spend some time on resilience. The app validates the integrity of the platform. That's why this is important. This is what's called defense in depth. It's never 100% secure. Security practitioners, security researchers eventually can overcome the app protections. It's a business level decision. What are you trying to hide, and how much do you want to spend to protect it? For financial applications, yes, resiliency is incredibly important. Layers of resiliency is important. They do not want researchers, they do not want malicious users digging into their applications. They don't want them testing them. They don't want them instrumenting them. They don't want them copying them. The more layers of resilience they can add on, the harder it makes it for my team. And we're looking to do good, but the harder it makes it for those who are looking to do bad. And that's the goal. It's not necessarily to prevent everything. It's not necessarily to prevent you from doing anything. It's supposed to make it as difficult, as time-consuming, as unattractive as possible so that those individuals move on to the next app. That's why we recommend resiliency, though, because if you make it hard enough and it's worth the spend, it's worth the investment, it's worth the resources, your app becomes unattractive and the attacker moves on. They move on to an easier target. They're looking for easy targets. So with the parting thoughts, MASVS, MASTG, they really do help you prepare your app for release. If you've got a security team internal to your organization, if you've got an external security partner that you're using, or maybe multiple, we work with plenty of companies that are here today that engage multiple different pen test vendors, multiple different security automation, testing, instrumentation vendors. It's a lot, right? It's a lot of resource commitment, but it's also a lot of pressure because these issues ultimately come back to the development teams. I know at Now Secure, we work with a lot of security teams who are shifting left, right? They're implementing the DevSecOps sort of perspective. Our software is actually feeding every single build, feeding bug reports back, talking about each one of these issues that I've talked about. The important thing is, if you're aware of them, if you know what you're being tested against, this is kind of like your exam cheat sheet. You already know what you're being tested against now. Now you can prepare. Now you can work, you can plan accordingly that this is my standard. This is what I'm being held accountable for. And the great thing about these standards, these in particular, is they're kept up to date. So they are advancement aware. Unlike so many other standards, we can point to certain NIST standards out there today, but they're older. Because they're such a large organization, they move slowly, right? They need community input. They need validation, revalidation. And so often by the time a new version of a standard comes out, it's already 2 years out of date. MASVS, MASVS, the OWASP community, they're constantly working with the community. They're an open organization. They're working with NIST. They're working with global compliance entities. They're working with European Union. They're incorporating GDPR requirements. They're incorporating everything into this standard. And that's why it's so important, because you can go here and know what's expected of you regardless of what rigor you expect to undergo. If you plan that your app needs to go through GDPR, if you think your app will need to go through CCPA, all of these different privacy acts, this is a great first step, because all of the privacy specific, now it focuses more on the client side versus maybe the data handling side, but this is always a gotcha. Every time we have a medical device manufacturer, they say, well, my device wasn't approved. I had to go back to the drawing board. Why? Not because my architecture was incorrect, but I didn't design my device correctly. I didn't design my app correctly, and I didn't consider the security and privacy implications, and it got rejected. It got kicked back. Now, one last thing with the 30 seconds that I have left is to talk about a program called MASA, the Mobile Application Security Assessment Program. It's quietly been rolled out. I talked about it a little bit yesterday in a lightning talk. This is even more of a lightning talk right here to talk about it. The App Defense Alliance is a Google-specific sponsored alliance of industry partners and experts. They have based a mobile-specific standard off of the MAS-VS that I just went over a little bit about. They chose 32 of the most important controls, and they said, this is our expectation for a baseline implementation of security and privacy that we want to see for all mobile applications in Google Play. So this program started out, it was invite only, quietly started rolling it out to the community. Now it's open to everyone. The interesting thing about this is an independent security review. See here, in your actual Play Store listing, you can get a badge if you go through this program that says you have been independently security reviewed. That lasts for a year until you need to go through that program again. Right now, it's just the badge in there. The interesting thing is it's starting to become more visible. Washington Post picked it up. Wired picked it up. They're starting to notice who's who amongst the list of already validated companies. Big names in there. Google's sending their own apps through an independent review. They won't even do their own validation. They send it out to one of 6 authorized labs throughout the world. Now Secure being one of them. Now, the interesting thing about this is what we anticipate Google will begin rolling out over the latter half of 2023 and into 2024 is starting to provide incentives for being part of this program. So it's an opt-in program, but they'll start to provide additional incentives. We don't know what those will be. We've heard talk of priority app listing, specific directories, Google marketing events. We don't really know yet what they will do, but they have definitively said that this is only the first step in the program, and it will only it's only starting, but it will definitely become more visible within the community as they place more and more of an emphasis on it. The reason I bring that up is because Now Secure being a authorized lab, something that I would like to offer to the DroidCon community is if you come up here, grab a card from me. This card, if you fill it out and give it back to me, I think our booth is already starting to tear down, so don't take it downstairs. Bring it right back to me. We can get your app a free MASA validation. So we will not only take a look at your app, we will actually send you through the entire validation process, and we will get you on that directory, and we will do it for free. The only thing that we're asking from you is a commitment that once we actually identify any issues that prevent you from being on that listing, make the commitment to resolving those issues, and we'll get you on there. And with that, I'll leave you with a few parting resources. We do have frequently some tech talks working with GitHub Copilot. We do have an academy, lots of free developer-centric courses, especially around secure mobile development. If you thought the Frida components were especially interesting, check out our academy as well. We have even more interesting information. By the way, the creator of Frida actually works on Now Secure's research team. So if you have an interesting topic around Frida, hit us up. We'd love to have a tech talk around that as well. And finally, we do have lots of interesting blog posts. Again, I threw up the one here around web views and how those are exploited with Frida. I think that's an especially interesting one. And with that, thank you everyone for attending.